This is Mrs. Kidman, and in this video, we are going to be discussing what the greatest common factor is and how we can find the greatest common factor of a polynomial. So when we look at the greatest common factor, really what we're looking at is what is the biggest term I can pull out, or what is the most that I can pull out from the polynomial that I'm looking at. So the biggest term, the most I can pull out. Now let's just start by looking at that greatest common factor with some numbers. So with the numbers, what we're looking at is the biggest number that goes into these two things. Well, when I think of the numbers that I can multiply to get 8, I multiply 1 times 8 and 2 times 4. The numbers I can multiply to get 12 are 1 times 12, 2 times 6, and 3 times 4. What is the biggest of these numbers? Well, the biggest number is 4. So the greatest common factor between 8 and 12 is 4. Now, as I look at these numbers, I can think of what numbers go in there. Well, these are all multiples of 5. So 5 can go into all of them. 10 goes into these two, but not this one. So our greatest common factor here is going to be 5. And again, we can look at that by evaluating what are all of the factors that I have of these numbers. And as I evaluate each of those factors, I can see what is that greatest common factor. So as I look through these, notice the bigger the number, the more factors that it has. But as I evaluate all of these, I can see that 5 was my greatest common factor. Now with 12 and 20, same sort of thing. I can evaluate those. So what I want you to do is take a second, pause the video, figure out what the greatest common factor of those two things are. Write out all the factors, circle the one that's the biggest. Then unpause the video when you've got it. Okay, hopefully you've had a chance to write out all of those factors, and we can look to see that our greatest common factor here is going to be 4. Now, I do want you to notice that in some of these cases, in all of the previous cases, that was the only common factor we had other than this first one. Notice how there was 2's here. In this case, 2's are our common factor and 4's are our common factor, but we want the greatest or the largest common factor. Therefore, 4 is that greatest common factor. Now we can do this exact same thing when we have polynomials. And in this case, we're going to look at some of these situations in which we have these monomials. So what's the most stuff that these have in common? Well, this one is 6 times x times x times x. And this one is 20 times x times x times x. Or 20 times x times x. So we can figure out what the factors of 6 are to figure out what they have the most in common. So we want to first figure out what is the greatest common factor between those coefficients, or that 6 and that 20. Well, the factors of 6 are 1 and 6, and 2 and 3. The factors of 20 are 1 and 20, 2 and 10, and 4 and 5. So the greatest common factor here is a 2. So I know that I can pull out a 2. The other thing that I can pull out here is notice how there's 2 x's here and 2 x's here. I can pull out, or I can say that they also have 2 x's or an x squared in common as well. So when we're talking about what's the most things they have in common, it's that x squared there. Now let's take a look at this next one. We're going to do the same thing. This is 12 times x. This is 28 times x times x. Notice they both have an x, so we can pull that x out. And then the greatest common factor between 12 and 28, well, that's going to be 4. So this will pull out to be a 4x. And again, we can list out all of those factors just to double check if you need to. But as we list out those factors, be aware that if you know what it is, you don't have to list it out every single time. So our greatest common factor here was 4, and there was an x. Now we can do the same thing here. I'm not going to write out all of my x's. Notice how there are 11 x's here and 15 here. The number of x's we can pull out is always going to be equal to the least number. So in this case, it's going to be 11. So I can pull out 11 x's here. And then I need to look at what are those factors of 14 and 35 that they might have in common. And I want to pull out the greatest one. So the factors of 14 are 1 and 14 and 2 and 7. The factors of 35 are 1 and 35 and 5 and 7. So 7 is my greatest common factor. So the most I can pull out here is a 7x to the 11th. Now, we're going to talk about how we find greatest common factors of polynomials. So when we're looking at these greatest common factors of these polynomials, what we might end up noticing is that these numbers will vary. So say, for example, I have the polynomial 3x squared plus 9x. Now notice how I have these two polynomials. There are these two monomials that make one polynomial, and I want to figure out what can I factor out, or what is the greatest common factor between these two things. So just like we did in this previous page where we evaluated what the common factors were between their coefficients or the numbers in front and the variables, we're going to do the same thing here. So a common number between 3 and 9, well, a common factor that goes into both of those, the greatest common factor is 3, and I have 2 x's here. This is an x to the first, and 1x there, so that means I know I can pull an x out here. So as I'm factoring this, what happens is I'm going to pull out what's in common, and I need to now write down what's left over. So if I pull out a 3 and an x, remember 3x squared is 3 times x times x. So if I get rid of a 3 and an x, what's left over? Well, there's an x inside here. This is 9 times x. And to get 9, that's a factor of 3 and 3. So if I get rid of one of those 3's, and one of our x's, what's left over is a positive 3. So notice how we factored that out. Now we can use our distributive property to get that same thing. We're just going backwards. When we're factoring, we're doing the opposite of multiplying. It's kind of like we're dividing here. And we can see that that ends up being the same. But the greatest common factor between these two numbers was 3x. Now, as you look forward to doing your assignment, we're going to be doing these examples over and over. You can see here, this is what our assignment's going to look like, that we are going to look at what numbers are in common between our coefficients and what is in common between our exponents. So let's take a look at the first 4 problems on our homework all together. After you've done that, hopefully you'll feel confident in your ability to do this. So this first problem, we want to look, what is something in common between negative 100 n squared and negative 30. Well, I know for sure that 10 goes into both of those, negative 10 goes into both of those, right? Negative 10 goes into 100 because negative 10 times 10 is 100, and negative 10 times 3 is negative 30. So I know I can pull out a negative 10. If I have 2 n's here and 1 n here, I also know that I can pull out an n. So as I pull these things out, I have to write down what's left over. So if I pull a negative 10 out of my 100, so negative 100 divided by negative 10, well, that's going to leave me a 10 inside. And if I get rid of one of my 2 n's, I'm left with an n inside. Then the same thing here, negative 30 divided by negative 10 is 3, and then I'm getting rid of this n. So there's no n that's going to be there. So then I want to double check, is this the greatest common factor that I can pull out? Well, there's nothing else in common between 10 and 3. Their only common factor is 1, and there's no more n's. So this is what we get when we pull that out. Now, I want you to try this next one on your own. Remember, what's in common between our coefficients and what's in common with our exponents. If we have 10 of something and 7 of something, that means I can for sure pull out 7 of it. So I want you to pause the video and try number 2 on your own. When you've finished, unpause the video and come back and we'll go over it. Okay, hopefully you had a chance to go over that one. Notice I listed out all of the factors of 20 and 50 here, and I saw that the greatest common factor between 20 and 50 and negative 50 was 10. So I know I can pull a 10 out of this problem. I know I can find that factor of that. Now looking at my n's, if I have 10 n's, 3, 4, 5, 6, 7, 8, 9, 10 n's here, and I have 7 n's here, I can pair up 7 of those and pull them out, right? So I can pair up 7 of those n's and pull them out. And then what am I left over with? Well, those 3 n's. So when I am factoring this, I can pull out 7 n's from both of them, and I'm left over with 3 n's in that first one. So I can factor out a greatest common factor of 10n to the 7th, and I'm left over with 2n cubed minus 5. So really, as we're factoring out this greatest common factor, what we're looking for is what is the most things that these two things have in common that I can factor out. And once I pull it out, I want to write down what's left over once I pull out those factors. If you have any questions, feel free to reach out. Otherwise, good luck on your assignment.